Hello, algebra students. Welcome to this introduction to the absolute value function. So to introduce this, I'm going to show you some things on Desmos. So we know the line y equals x. It has a y-intercept of 0, 0, and a slope of up 1 over 1. So let's zoom in so we can see that, right? Up 1 over 1, up 1 over 1. But we know things that, like the absolute value of -3, see how it says it equals 3. And we know what absolute value means. So we just want to investigate what would it mean if I put a variable inside the absolute value of x. Like, what is that going to look like as a graph? Well, we know that the output's always going to be positive. So what's interesting is if I take the graphs of y equals x and the graphs of y equals -x, and what I do is I restrict their domains. So currently their domains are -infinity to infinity, like all inputs have outputs for both the blue and the red line. But let's say I only want the positive outputs, because I know an absolute value, I'll only get the positive outputs. So I'm going to say, hey, x has to be greater than or equal to 0. So that way I only have the positive part of the red line. And here I'll say x has to be less than 0. So if you look at that, it makes a perfect V. And this is actually what our absolute value function is going to look like. And to show you that, like, this is the definition of absolute value if you make it as a piecewise function. If I add a table, and let's think about if our y1 equaled the absolute value of x. So let's say our input was -3. The absolute value of 3, it's not letting me type that, so that's fine. The absolute value of 3 would be 3, right? You just take the positive version, like how many units from 0. The input's -2, the output is 2. See how this is lining up on that line? If the input is -1, the output will be 1. If the input is 0, the output is 0. Oops, not 1, 0. Input's 1, output's 1, right? Because the absolute value of a positive number is just itself. And notice how all these lines I'm graphing end up on these two lines. So let's see what our absolute value function, I'm going to write it as a function, it's f of x. So absolute value of x. There it is in blue. Let's change the color. Let's make it green. So now you can see the green on top. I can select it and deselect it. So the absolute value function can actually be written as a piecewise function here with these restricted domains. And it looks like this V because you always have positive outputs. So its domain would be -infinity to infinity, right? All inputs have outputs, think from left to right. And its range, its smallest y value is 0, and it goes up towards infinity forever, so its largest y value would be infinity. So this is what the absolute value function looks like. These would be the parent points. If you look right here at this table, these points will always be on the absolute value function of x. And this has been an introduction to this parent function of absolute value of x.